Hello everyone! Welcome to the SimLab Nonlinear Static Analysis Flex Plate tutorial. In this video, we will demonstrate how to set up a nonlinear static analysis with multiple load cases. The first load case will address the pretension of our model, and the second load case will involve the applied load. We start by importing our GDA file. Next, we navigate to the advanced ribbon and select the bolt modeling option. We then choose the Create Bolt tool and define the washer and thread surfaces. After that, we click OK to execute the action. Finally, we merge the models in our assembly browser. We proceed to check the quality criteria of our mesh. First, we navigate to the Mesh ribbon and select the drop-down menu in the Verify toolbar, where we choose the Quality Criteria tool. We ensure that both trias and tetras elements are free of errors. After this, we validate our model for axis symmetry, ensuring that there is node-to-node symmetry, which will be necessary for the subsequent creation of multi-point constraints later on. We navigate to the Solution ribbon, select the Structural Solution icon, then choose Static Stress Analysis. We define it as nonlinear static and select all bodies in our database. Next, we proceed to create a cylindrical coordinate system and assign it to our specific solution. Next, we will create multi-point constraints between the symmetry nodes in our model. These constraints concern the dependency on the radial direction of our previously established coordinate system. We need to perform this action for each pair of symmetry faces. This step is essential because our second load case will involve a radial acceleration based on a constant rotating speed. We should always remember that the tolerance must be a number greater than the maximum distance between our symmetry nodes. Additionally, when selecting the cyclic MPC option, the order of our chosen nodes is very important because it needs to be an exact mirror based on our axis of symmetry. When creating contacts, it is important to always consider using the Auto Contact tool. This tool is very easy to use and it allows us to differentiate between planar and cylindrical faces and also set the tolerance between bodies. In this specific example, we will use two types of contacts, 2 friction contacts and 1 freeze contact. We can also quickly visualize and edit our contacts by using the Contact Manager tool. We will now create the 2 load cases required for our simulation. The first load case will focus on pretension, while the second will involve the application of an external load. After creating the second load case, we right-click and activate the first one, so that we can work on it. We apply symmetry and fixed constraints. For the first load case, we also add the pretension load to the bolt. Afterwards, we define the local settings by editing solver settings and result requests. Next, we activate our second load case. In this step, we transfer the constraints from our first load case and apply a constant rotating speed along with an enforced displacement. After that, we define the local settings by adjusting the solver settings and result requests. It is important to remember to include the previous load case in the solver settings. We activate the global settings as well. We define the CNTNL sub-entry to make sure that we will have load case continuation. Afterwards, we enable the format and execute options, and we set the number of processors equal to 4. We assign our material, in this case steel, to all bodies involved in the solution process. The material is defined as linear elastic. After assigning the material, we are ready to run our solution. The final step involves post-processing in SimLab, where we can visualize and inspect stresses, strains, and displacements in both load cases. We can also perform section cuts and create plots.